And this is my presentation for the class project. As the topic of my project, I had chosen the Lotus Riverside building complex, building block number 7 that had collapsed back in June 27th of 2009. This building is located in the Minhang district in Shanghai, in China. And as part of this presentation, I will be going over the what, the how, and the why that led up to the building collapsing. The what? This building complex is a residential building complex, and it was originally designed to be an 11 building complex, and it actually does house 629 units, apartment units. These apartment units, at the time of the construction of this building complex, were being pre-sold. And this is important because the building at the time, the building in question, the building that is the subject of my presentation, was unoccupied by the number of residents that would have otherwise occupied this building had they finalized construction and people were allowed to move in. Luckily, there were no residents living at the time of the failure that I will be mentioning to you. And like I said, it was block number 7 of this 11 unit residential building complex that unfortunately failed, and I will be going over how and why that happened. This construction site itself at the time, and it is now located adjacent the south bank of the Dianpu River in Shanghai, and this is a premium location of Shanghai as far as residential living goes. So this is a bit of a high-profile area to begin with, and the failure of this building which has brought international attention, is not something to be taken lightly. And the foundation system that was utilized throughout the entire 11 building complex was a pre-stressed, precast pile supported grade beam system, and each individual unit would have had its own separate foundation system that consisted of these precast, pre-stressed piles that were driven into the ground at a depth of about 40, 50 feet until the bedrock was met. I would like to start off by going over how this building collapsed and met its unfortunate end. After building number 7 of the complex was constructed, and it was in very, very final stages of construction and having the interior being finished out, after it was constructed, work began on one side, on the side opposite where the riverbank is, of constructing a parking garage, an underground parking garage, which meant that they had to excavate and create the space for this parking garage, which is adjacent to the building number 7. And they took the soil debris, the excavated debris, and they piled it on the opposite side of this building, which is a 13-story high apartment building, and they started piling it on the side of the riverbank, and they didn't remove it off site. They kept that debris on site in trying to minimize cost and time, and so they started storing this debris, the excavated dirt, on the opposite side of the block number 7. And the resulting this debris was on the north side. It was piled on the north side, and unfortunately, what the construction team didn't realize was that this was rainy season, and rainy season meant that there was a lot of rainwater seeping into the ground, and a lot of rainwater just saturating the soil everywhere. And in this case, the pile of dirt that was piled on the north side of the the apartment building, which is 13 stories high, it started getting saturated with all that rainwater that was coming down because the rain was pretty heavy during this time period, and where when this incident happened. The pile of dirt was piled as high as 30 feet, approximately 30 feet in height, which is 3 stories. When you think about it, it's pretty high, and to be piling some dirt, and it's not a small matter. At this point, this is a large mass of dirt, and so now the rain from the rainy season and it being so close to the river there starts saturating that pile of dirt, and the pile of dirt in turn starts exerting pressure on the river bank, side where it was piled, and the dirt pile itself now starts sinking. It starts sinking next to block number 7. As this pile of 30-foot high pile of dirt is sinking, it's compromising the riverbank, and there's no other place for the soil to go because you have the seawall on the one side from the riverbank, and then the soil now is saturated and it's sinking. So it's trying to find the path of least resistance, and in this case, because they were digging a giant hole for this underground parking garage on the opposite side of block number 7, that kind of helped the soil to displace laterally and move laterally underneath the foundation system of block number 7. And this lateral displacement of the soil, because of a pressure difference underneath, it runs into the foundation system of block number 7. The block number 7 foundation piles are in the direct path of this soil that's now moving laterally with substantial mass and it's a substantial force at this point. It's a force to be reckoned with. And because of this lateral movement, which is unaccounted for in the design of the foundation system itself, the soil starts exerting a huge amount of lateral loading on these piles, and some of the piles started snapping, and they break because of all the soil that's moving underneath them, which they're not intended. The piles themselves are not intended to experience that kind of loading, and some of the piles start failing, and unfortunately, there seems to be a bit of a domino effect, and the building starts tilting now. And as the building tilts, the remaining piles break off because they are designed to work as a system with the entire strength of the pile system being in place. But when a few fail, the rest of them fail, and this building at that point starts tilting towards the side where they were excavating the parking garage, and it falls over. And it falls over with considerable noise, and people around it for several miles have heard the noise of this building falling over. And this is the unfortunate aftermath of this pile of dirt that was being piled on the north side of the building because they were digging the underground parking garage. The piles themselves, they snap, so they look like twigs have been snapped off. Portions of these piles are still, they're still tied to the rest of the foundation of the grade beams, and so with the rest of the building, they break, in the middle or somewhere along the middle, and they still stay intact, attached to the building, and you can tell where, if you look along the side, if you took a look from the side, you can tell how the piles themselves all seem to have been snapped off about the same length away from the foundation, the rest of the foundation of the building itself. And you can see some of the piles lying there, and they are hollow core piles. And this is important to note, and I will touch base on the use of the hollow core piles and their performance value a little bit later on. And in this one picture where I have a circle placed on the dirt is actually the dirt pile that they had, unfortunately, without regard, piled up after having excavated the parking garage. They hadn't fully excavated the parking garage. They had only gone to about 12 feet in depth of excavation, and this is the resulting amount of dirt. Imagine if they had kept going, then the dirt pile, they might have, piled it higher, and that would have, caused the same amount of failure. But it's unfortunate that they didn't realize that this soil was going to have such an impact. And the why. And we're getting to the why portion of the presentation now. The pile support foundation is a clue to the construction and the subgrade of this site. Because it's so close to a river, the river bank itself is right next to this building complex. It seems that they had chosen a pile supported system because the subgrade itself was of poor quality, and perhaps the subgrade was deemed not suitable for a more conventional footing system. And so during perhaps soils testing, they might have determined that a pile-driven pile system would much better suit this building site. And so that kind of gives you a clue as to the sensitivity of the building site to begin with. And the piles of the foundation system, they were designed to a certain allowable or design bending moment and shear stress capacity. And unfortunately, the dirt that sank, the dirt pile that was piled up after the excavation of the parking garage, as it sank, it obliterated these design capacities that were taken into account at the beginning of the design phase, but nobody would have taken into account this extra lateral loading that came about from this pile of dirt. And this is the lateral loading, the pressure that exerted on the piles themselves that snapped that rope trim. The pile size would have been chosen. That would have been chosen would have had a certain deflection limit. That perhaps these were standardized piles. It seems that they used on the project, so they might have tested. They definitely would have had written specifications as to what the deflection limits of these piles were. As the dirt was sinking, the dirt pile was sinking, it exceeded obviously the bending moment and the shear capacity, the shear stress capacity of these piles, and caused abnormal deflections, I'm sure, and that would have been a visible sign. If you could have taken an underground look, an X-ray, so to speak, you would have seen the piles deflecting more than the allowed limit in the normal capacity to which they would have been designed in the first place, for this job site. The piles of the foundation system were designed expecting a certain uniform skin friction, and the pile itself is meant to be held by the dirt, the soil, the subgrade that's surrounding it, and that soil exerts skin friction on the pile, the length of the surface, and the sinking dirt kind of would have washed away almost, or pushed away the soil that was exerting this skin friction pressure around and holding these piles in place. And as that dirt was being laterally displaced, the friction, the skin friction of these piles would have also decreased. Not sure exactly if it would have been in a progressive loss of the skin friction, or if it was almost entirely sudden. But this was another reason why the piles might have failed, because the piles now, after this, the soil pressure has moved away from that was holding these piles, so to speak. Um, the piles themselves are going to experience some sort of a cantilever situation where they're not meant to do that type of um, work. The piles that were used on this foundation system of block number 7 that failed it was a pre-stressed precast piles. And one thing to note about these piles, this type of pile, is there's many different types of piles, and this specific pile that they've used is a hollow core. Like I mentioned earlier, the hollow core is important because they used a water jetting process to form these piles on the ground. And unfortunately, the hollow core nature of these piles means that these pre-stressing cables are in place, and also maybe only spiral reinforcement that's placed in the wall of each pile would have had to take the brunt of the tensile stresses that would have resulted from this soil that's moving around underneath it. And obviously, that's the rebar tie, or the tie bar, was not enough to do the work of pulling back or counteracting counteracting the load that was being exerted on laterally. And we had building failure because of the foundation system failing due to the nature of these piles. There's nothing wrong with the pile itself and its design, really. It's weaker in dealing with these lateral loads and radially as well. And it's just, under normal circumstances, these piles would not have gone this much stress, and they might have performed, because the other buildings in the construction site are doing fine. And if you notice in one of the previous pictures, they had piles of dirt that are sitting next to those buildings, just like the one that failed. Unfortunately, this one, perhaps it being, a couple of different factors came into play, and it caused the dirt to move and ultimately fail the building itself. Hypothetically, this question has been on the forefront of my mind. If the piles had been solid, if they were solid, solid core, perhaps octagonal in cross section, as is the norm for construction projects here in the U.S. They use these octagonal piles as opposed to these hollow core round piles. They're not almost used for building projects of this sort. They're used more for marine applications. And so, hypothetically, I wonder if they had used solid piles with full rebar cage, this might have been prevented. But that is, like I said, hypothetically speaking, it's just purely something that is up to as an afterthought. In closing, I want to just point out the fact that, ironically, this building, the Lotus Riverside block number 7 that fell over, bears the name of the Lotus plant, and that plant thrives in aquatic habitats with minimal footing in muddy, murky waters that don't offer the stability of a nice soil. Perhaps if the hollow perhaps the hollow roots of the lotus plant, when you look at it, could have provided a better design suggestion for the pile design and the chosen type of pile. And even if the failure of block number 7 was ultimately due to the negligence of the construction, methods and means and methods that were practiced. There was unfortunately one fatality of one of the workers, but the larger loss of life had been averted because this building was not occupied at the time. And this is the end of my presentation. I hope this gives a glimpse into why this building collapsed, how it collapsed, and the overall background of the building as well. Thank you very much. Bye.